Now we're going to take a look at graphing secant and cosecant. So secant and cosecant rely on you being able to graph sine and cosine. So this will be a review of graphing sine and cosine, and then we're adding little bits and pieces onto it. Okay, so you use the graph of sine and cosine to get you to your reciprocal. So you do need to remember that cosecant's the reciprocal of sine and secant's the reciprocal of cosine. So notice here that we've got, this is our sine wave that we have going on here. Okay. Notice at 0 it starts in the middle, that's our positive sine wave. Okay, I totally pointed to the wrong spot. This is 0. That's our positive sine wave. Okay. The x scale is not nicely done in radians. It's just done with your normal numbers, but it still hits at your same value of 2 pi. Okay. So what you do is you draw your sine graph right here. And then where your sine graph hits the midline, you're going to make asymptotes. So here would be an asymptote, here would be an asymptote, here would be an asymptote. And then you're going to use those asymptotes to help you create these parabola-like shapes. So from the max of the sine graph, you're going to create this parabola-like shape. And then from the min of the sine graph, you're going to create this upside down parabola-like shape. Okay? And that's how you get your cosecant graph. So we use the same way of graphing sine to get there. So I'm going to rewrite this over here. Oops, not what I wanted to do. Now remember that we need to factor out the 3 before I do anything. So I factor out my period change out of the horizontal or phase shift. So what we're doing when we're factoring is we're really dividing. So I'm taking negative 3 pi halves and I'm dividing that by 3. Well, dividing by 3 is the same thing as timesing by a third. So then our 3's can cancel, so that's really a negative pi halves. So this is x minus pi halves minus 1. If you struggle, you can always check backwards and do 3 times pi halves. Does that give us 3 pi halves? Which it does. So now this means that we're shifting right by pi halves. We're shifting down by 1. The amplitude is changing by 2, and the period is now going to be 2 pi divided by that 3. Okay. So I start with my midline. So I'm going to go down negative 1. Then from there, I'm going to use this 2, which is the amplitude, and I'm going to go up 2 to get to my top line and down 2 to get to my bottom line. So I've got my max and my min. Did not draw that bottom one very well. So now I'm going to figure out my starting point, where our starting point is the opposite of inside here. So negative pi halves means that it goes to a positive pi halves. So we're starting at pi halves. Okay? So that is my starting value. So remember, to find our end value, you're going to do the start plus the period. Okay? The period in this case is 2 pi divided by the b, just like it's always been. The b in this case is 3. So this is going to be, where did it go? Where's my starting point? Negative pi halves. No, positive pi halves, sorry. I don't know why that's randomly a negative. I don't know what I was saying there. You're going right by pi halves. I don't know why it was negative, sorry. So pi halves plus the period, which is, oh, I know. It was negative from there. This, I was simplifying that, which gave it negative, which then means that you're going to the right. Equals. There we go. Feel better now. So we take our period, which is 2 pi thirds. Now, if you're not great with fractions, you can use your calculator again. So we can do 1/2, so just take out the pi, plus 2 thirds, and you can math bracket. So that gives you 1.6 or 7/6. So if I do 7/6, I'm thinking in terms of, if I look here at my tick marks, I've got 1, 2, 3, 4, 5, 6 per pi, which means that if I want 7 pi 6 as my endpoint, that means I'm going to do 1/6 past pi, which is right here. Okay. So that's my endpoint and this is my beginning point. So if I'm looking at how far it is from 7 pi 6 to pi halves, so if we do 7 6 minus 1/2, and we math bracket, that gives us 2/3, which is what the period is, which is what we want. We want this length here to be the period. Okay. So we're going to take this amount and cut it in half, and then cut the first half in half and the second half in half. So I took this amount, cut it in half, this amount, cut it in half. Okay. So now I'm going to draw my sine wave, but I'm going to do the sine wave as a dotted line. So since it's a negative, my sine is going to go middle, bottom, middle, top, middle. Okay. So I'm going to have middle here, bottom, middle, top, middle, and I'm just going to do this little dotted line because I need that sine line to help me get to the sine graph, rather, to help me get to the cosecant graph. Okay. So now, since it's cosecant, I need to do where it hits the middle. All my asymptotes are where it hits the middle. Let's see, what color have I not used? Blue. Okay. So here at the middle is an asymptote, here at the middle is an asymptote, and here at the middle is an asymptote. So then I'm going to take the min and max from my sine graph, so here's my max, and I'm going to create this parabola-like shape. Again, it's not really a parabola because it's bounded by these asymptotes, so it doesn't go out for forever, but it has that look to it. Okay. So then the only part that's the cosecant graph is the green part. Everything else is just to help me to get to it. The blue does represent the asymptotes for your cosecant graph. Okay. So if we look at our next one, we've got y equals 1/2 cosecant 1/2. When I rewrite it, I'm just going to factor it out. So if we're taking 1/2 out of pi fourths, that means we're dividing. When you factor, that means dividing. So I'm going to flip and multiply, so 2 over 1, so the 2's cancel, so minus pi. So x minus pi. Again, I can double check. If I distribute this through, 1/2 times by x is 1/2 x, and 1/2 times by pi is not pi fourths. I missed something. Oh, I randomly changed the 4 to a 2. Let's not randomly change numbers, so that's a 4. So then that'll cancel to a 2. So then pi halves. So now if we double check again, 1/2 times x is 1/2 x, and then 1/2 times by pi halves is 1 times pi, which is pi, and 2 times 2, which is 4, so pi fourths. So now I've done it correctly. Okay. So then we're shifting right by pi halves, is what this part tells us. And we're shifting up by a half. So I'm going to start with my midline. I'm going to go up a half, which is a smidge, and then our amplitude is a half. Oh, I made that very squishy. So I'm going to go up and down by the a value, so just all right in there. Okay. And then the period we find by doing 2 pi divided by b. So our b in this case is 1/2. So when I flip and multiply, that gives us 4 pi. So I need to start at pi halves but end at 4 pi. So I'm going to rescale. So I'm going to do, got a space for every 2 to be a pi. 1/5 part, yeah. Okay, so that's going to be pi, no, I said every 2 is a pi. So pi, 2 pi, 3 pi, 4 pi. Okay. So if we're starting at pi halves, that's this value here. So we're going to go right by pi halves, which is going to start us there. And then we're going to find our end value by doing the start plus the period. So the starting value is the pi halves, and the period is 4 pi. So that'll get us to 4.5 pi, which is the same thing as 9 pi halves. So our ending, let's see here, let's try that color. Our ending is at 9 pi halves. So here. So I'm starting here and I'm ending here. So I'm going to take this amount and cut it in half. Okay. So if we're going to take this amount and cut it in half, I'm going to go to here. And then I'm going to take this amount and cut it in half, which is there. Oh, I went from pink. No, purple. This amount cut it in half. So there and then there. Okay. So we're starting here, go to here, go to here, go to here, go to here. So then our cosecant graph is a sine, a reciprocal of sine. So I'm going to do middle to top to middle to bottom to middle. So I've got this little teeny wave. Okay. Then my asymptotes are going to be where it hits the midline. So it hits the midline here, hits the midline here, and hits the midline here. And then I'm going to take the max of the sine and create that parabola-like shape. And then the min and create that parabola-like shape. Now, that was cosecant. Secant's very much the same except for you're doing cosine instead of sine. So notice here our parent graph. This is cosine. The asymptotes are still where it hits the middle, but there's only two middles in cosine. So there's only your two asymptotes. And then it will create, if you're just doing one period, it will just show this part of the graph. So you'll end up with like a part of a parabola and a part of a parabola-like shape on these two ends because you don't have this part drawn. Okay. So let's take a look what this looks like. So here we're shifting down by 1. The amplitude is up by 1 and down by 1, so that's our min and our max. Then the period is 2 pi divided by b. The b is the thing being multiplied by the 2, so that, or by the x, which is 2, so that gives us pi. We have no shifting value, so I'm starting at 0. Okay. So start at 0, so then that means that we're ending at 0 plus pi, which is pi. So a nice, more simplistic one. Okay. So we start at 0, we end at pi. It's a secant graph. Secant's the reciprocal of cosine. So I'm going to draw my cosine graph. It's a positive cosine. So I'm going to start at, oh, I forgot to do my tick marks in half. I'm going to take this amount, cut it in half. And then I'm going to take the first half, cut it in half, and the second half, cut it in half. So then we're going to do, secant goes from the top to the middle, to the bottom, to the middle, to the top. And I'm just going to make that a dotted graph. So we're just using that to get to our other graph. It's not actually part of the secant graph. Then our asymptotes for secant are located where the cosine hits the midline. So right here and right here. Okay. So then you still take your min and your max values. So this is my max of the cosine. And I'm going to create a parabola-like shape, or in this case, like a half a parabola that pulls towards it because we don't have the other asymptote over here. It would repeat, right? So eventually you'll have just the parabolas up and down shape. So if you look between your, so here was our parent function and here was our parent function, right? So you still have u's going up and down. They're oriented in different spots. Like this one splits the y-axis, whereas this one does not. Right, so that's because sine and cosine are shifted off of each other by 90 degrees. Okay. So we're going to take this minimum value and create that parabola-like shape. And then we're going to take this maximum value and create that parabola-like shape. Okay. So we can do the same kind of thing with this one. We need to factor out the 1/4. Should have added like a more exciting value to the amplitude. Let's just tack a 3 in there because why not? So I'm going to factor out that 1/4. So if we do pi fourths divided by 1/4, that means we're going to flip and multiply. So 4 over 1, so the 4's cancel, so I get pi. So plus pi. Again, you can check. 1/4 times x is 1/4 x. 1/4 times pi is pi fourths, which is what we had. So I didn't mess up on any of my algebra skills. So then we're going to shift left by pi and down by 1. And then the period here is going to be 2 pi divided by 1/4. So that's going to give us 8 pi. Okay, so we're shifting down by 1. Then the amplitude is 3 because I changed it. So if you missed that, 1, 2, 3. I opted to change it. 1, 2, 3. Okay. Now here we have, we're starting at negative pi, and I'm ending, start negative pi, and our end will be the start plus the period, which in this case is 8 pi. So that means that I need to go to 7 pi. So I'm just going to scale, let's see here, we did 4 pi on the other one. Yeah, I'm going to go 1 as pi. So this will be pi, 2 pi, 3 pi, 4 pi, 5 pi, 6, 7 pi, and we're going to a negative pi over here. Okay, so I need to extend these probably a little bit. So secant's the reciprocal of cosine. It's a negative secant, so we're going to do a negative cosine. So our starting value, let's go, sure, we can do that color. We're starting at negative pi, and we're going to 7 pi. So I need to cut this distance in half. And then I'm going to take this distance and cut it in half. And then I'm going to take this distance and cut it in half. Okay. So all of my dark red or maroon ones. So now we're going to do negative cosine because it's secant. So I'm going to start at the bottom, but make sure that I'm starting at negative pi, right? Because that was our starting value. So I'm going to start at the bottom here. Then I'm going to go to the middle at the next tick mark, to the top of the next tick mark, to the middle at the next tick mark, and the bottom of the next tick mark. Again, since it's secant, I'm going to change, just write it as a dotted line. And then my asymptotes for secant are still where it hits the midline. So for both secant and cosecant. Okay. So then I'm going to use the max and create this parabola-like shape. And use this min and create this parabola-like shape. It'll be like a half parabola on these ones. Again, it would repeat to here. Right, but we're just drawing one period, so this is what it ends up looking like. So that's how you draw your secant and cosecant graphs.